Catalysis. There are two types of catalysis. One is known as heterogeneous catalysis and other one is known as homogeneous catalysis. Heterogeneous mean different phases. If the catalyst has different phase as compared to the phase of the reactants, so this is the example of heterogeneous catalysis. For example, Haber process, for example, contact process, and for example, catalytic converter. In Haber process, we react nitrogen with hydrogen to make ammonia gas, and here we use iron in solid state. So iron is heterogeneous catalyst in this case. In contact process, sulfur dioxide gas is changed into the sulfur dioxide gas, and here we use vanadium 5 oxide. So vanadium 5 oxide is in solid state. So this is also example of heterogeneous catalysis. In catalytic converter, we use rhodium to convert nitrogen monoxide, carbon monoxide into less harmful gases, carbon dioxide and nitrogen, and rhodium is also in solid state. So this is the third example of heterogeneous catalysis. Basically, during the course of a reaction, when there is the heterogeneous catalysis, reactants are absorbed on the active side of the surface of the heterogeneous catalysis. In case of impurities in the reaction mixture, they may bind at the active side of the catalyst and block the reactant for being absorbed at that side. And impurities may poison the catalyst. Homogeneous catalysis. Homogeneous catalysis mean when the phase of the catalyst and phase of the reactants are same. For example, reaction between peroxy disulfide ion S2OA 2 negative ion and I negative ion take place very much slowly because of the similar charges on both ions. They are both negatively charged species. So here we use iron 2 ion to catalyze this sort of reaction. The collision between these two ions is unsuccessful collision. But iron 2 ion catalyzes this reaction as it is a positive ion and can readily combine with the negative ion. First, iron 2 positive ion is oxidized to iron 3 ion by S2O8 2 negative ion, that is peroxy disulfide ion. In first step, there is the formation of iron 3 ion. Then this iron 3 ion react with the iodide ion to make I2 iodine and Fe2 positive ion. This reaction can be visualized in the enthalpy profile diagram. In this diagram, basically, when we put the catalyst, reaction change into two steps. First is the formation of iron 3, iron 2 to iron 3 as an intermediate and the formation of sulfate ion. And then the next step is when iron 3 react with the iodide ion to make iodine. So in this way, this reaction goes to the completion by making sulfate ion and iodine. Lock and key model. Enzymes are basically homogeneous biological catalysts. They react with the substrate and lower down the energy of activation by changing the path of reaction. Enzyme react with the substrate. Enzyme behaves like a lock and substrate behaves as a key. The first intermediate is formed, that is enzyme substrate intermediate. Then enzyme break the substrate into the desired product. So this is the simplest version of the lock and key model. So you can say that this is also a two-step mechanism. First, the intermediate formation takes place, then the final products are formed. Similarly, there is another type of catalysis that is known as autocatalysis, automatic catalysis. Some products, those are formed during the course of a chemical reaction, they act as a catalyst automatically. So they are known as autocatalyst. Autocatalyst profile diagram is shown in this diagram. Autocatalyst, how change the speed of a reaction or how it change the profile of reaction, that is shown in this diagram.